Okay, in this video, I'm going to go over the three types of angles that we have studied. Central angle, inscribed angles, and circumscribed angles. I'm going to compare them, give you an example of each, and then compare them and see how you actually calculate each one. Okay, so let's start with the first one, the central angle. Now, what's the definition of a central angle? Basically, it means that the vertex of the angle is in the center of the circle. Okay, so that's really important. So the vertex is at the center of the circle. Okay, now that really is the defining feature of a central angle as compared to the other two types, because for an inscribed circle, the vertex is actually on the circumference of the circle. Okay, so let's just put that down there. Vertex is at the circumference, or the outside edge if you want, or the perimeter, although we usually use perimeters for like hard-sided figures, but for circles we call it a circumference. So the vertex is at the circumference, and for a circumscribed angle, the vertex is located outside the circle, so out here, okay? Vertex outside circle. And because of that, they each have different kind of characteristics on how you would calculate them. So, for example, in a central angle, like right here, the number of degrees here, it'd be equal to the number of degrees of the arc. Okay, so the angle is equal to what they call an intercepted arc. And that's just for a central angle only. So if this were, let's say, 80 degrees, then this would be 80 degrees as an example. Okay, so if that were 80 degrees, that means that the arc is also 80 degrees. All right, and remember, the arc is that portion of the outside. Sorry about that. The arc is that portion of the outside of the circle. Okay. Now, for an inscribed angle, it's a little bit different. The angle itself is 1/2 the number, or 1/2 the measure of the intercepted arc. Okay, so the angle of an intercepted or inscribed angle is equal to 1/2 intercepted arc. Okay, so if, for example, again, let's say that the arc were 80 degrees, that means that the angle would be 40 degrees. Okay, you can always count on that. Now, for a circumscribed angle, it's going to be a little bit more complicated. Let me describe what happens here. A circumscribed angle has two rays, right, that are tangent to the circle. So let's do that first. Two rays tangent to the circle. Now, it doesn't have to be just a ray. It could also be just a line like this one, for example. It ends right there, or a line segment, But for a ray, remember, it would just continue on in both directions. But the point is that a tangent line intercepts the circumference at only one spot, all right? So there is just one point that intersects the circle. So that's what a tangent line does. The cool thing about tangent lines is that if you were to draw a line from where it intersected to the center of the circle, like that, and another one like that, let's do that, the angle that it forms is always 90 degrees. Okay? The angle that it forms is always 90 degrees. So tangent lines create 90-degree angles with the center of the circle. Let me write that down because that's really an important thing to do. Tangent lines create perpendicular, this is a symbol for perpendicular, remember, perpendicular angles or perpendicular lines to the center of the circle. Okay? But it also does something else. This circumscribed angle, notice, is a four-sided figure. Now, this particular figure is called a kite. Remember what a kite is? That means that there are two consecutive congruent lines. So this segment, this line, and this line are congruent, and then this line and then the consecutive line after it is also congruent. That's kind of important because in a kite, the opposite sides of a kite are always supplementary. Let me say that again, because that's, again, a little bit more complicated. I told you that this part's going to be a little bit more involved. All right, so let's say that again. So kites will always be formed by these tangent lines, right? Kites have opposite angles So this one and this one, for example, and this one, that are complementary. That are supplementary. And remember that supplementary means 180, they add up to 180 degrees. Now that makes some sense with our perpendicular lines, doesn't it? Our perpendicular angles. Since these are opposite each other, and we know that they are tangent lines, we know they form right angles, this angle and this angle add up to 180 degrees, which means that this angle and this angle must add up to 180 degrees. Now, why do we know that? We know that because in a quadrilateral, four-sided figure, there are 360 degrees that make up the internal angle of a four-sided figure. Remember that? If you want to have proof of that, just remember that a box or a square, if you add all those, again, a four-sided figure, has four 90-degree angles. Those equal 360 degrees. In fact, any four-sided figure has internal angles that equal 360. In this kite, no matter how stretched out it might be, the opposite sides always equal 180. That's actually pretty helpful, okay? Because if, for example, and notice that this is also now a central angle, because these tangent lines, when you create the lines, that perpendicular lines that go to the center, you now have a central angle. So this angle should be equal to this intercepted arc, which is what we learned back here. So if you knew this, for example, let's say it's 140 degrees. We know that this would have to be 40, right? Because this plus this angle and this angle must be supplementary, therefore it would equal 180 degrees. Okay? The other way to do it, of course, is to add up all four of these angles if you knew any one part, and you should be able to get up to 360 degrees as well. So, again, in review, central angles, vertex starts in the middle, goes to the circumference, the two angles, this angle and the measure of the circumference or the arc are equal. If it's an inscribed angle, vertex is on the circumference, it's 1/2 of the intercepted arc. And if it's a circumscribed angle, it forms two tangent lines, which in turn form perpendiculars to the center, forming a kite, forming two 90-degree angles here, which means that these are also supplementary, meaning they add up to 180 degrees. If you knew this one, you could calculate this, and if you knew this one, you could calculate this. Okay, that was a little bit long, but I hope that was helpful to you.